Good morning, everyone. So today we're going to go ahead and extend a little off we learned last week. So we started by making a Python script. We have Python installed now. So now we're going to make it a little bit easier to actually work with the scripts that we're writing. And specifically, we're going to start moving on to using a text editor. So previously, let me open my terminal here. Previously, we were just using Nano to write things. So let's say um, Python focus group. It's a good idea for all of you to go ahead and start navigating to where you have your Python focus group. And remember that this changed since now we're using GitHub Desktop, so it should be nested somewhere under GitHub now. But go ahead and change into your Python focus group. So previously, yeah, we were using Nano. So we'd say something like nano python script.py and it would pull up this interface. And it's always weird because you're trying to click Control X, you're trying to save it, you're interacting with it. Let's say you have multiple lines of stuff. You can't actually click where you want to and edit. So if you have a script that's, say, 100 lines long, now you're going to have to sit here with your down arrow to go to the exact line you need to find and edit it, which is really, really inconvenient. So we're actually going to switch to using text editors now, and that will look more like an interface like this. So this is actually a snake file that I've been working on, which we'll go into later. But essentially, now I have a script that's about 188 lines long, and let's say I want to change how much memory I allocated towards this. I don't have to open Nano and scroll down to line 175. I just kind of click around, I can highlight and replace things, so it's a lot more straightforward. And for those of you who are using Hive or a possible cluster environment, you can also eventually connect to the cluster environment like that. So we can add profiles and you can interact with your stuff on the cluster without having to do stuff at the command line, which is also really convenient. So one example here is, let's say we go into session 4, which I recommend all of you make now. And I say touch python script.py as an example. Now, if I open my text editor, or not my text editor, my file explorer, and I go to Python focus group, session 4, we see that I just created this Python script. And it has no content in it because it's just empty right now. But I can say open with, and in my case, I have Notepad++. So this will open the script directly, and I can type around and write in my Python script in a more interactive interface. So that's the goal of the beginning of today's session, is trying to get you all set up with a text editor that works for you. So ultimately, whatever text editor you decide to choose is largely dependent on your operating system. And it also depends on how complex you want something to be in the future. So, for example, VS Code is considered like one of the holy grails of programming. Everyone that I know that uses VS Code preaches about how much they love it. Personally, I like the simplicity of Notepad++. I like just being like, yep, this is my script. That's all I need for my script, and I can connect to the cluster and upload stuff. That's about the extent that I really want. I will do everything else myself at the command line. But VS Code, you can actually integrate like GitHub and you can push stuff from within it. Like it's really nice. There's all sorts of plugins that you can use. But again, it can be a little complicated. There's Sublime, which is a little kind of in between Notepad++ and VS Code. Generally, for people who have Macs, BB Edit is a pretty good one. So if you have Macs or an Apple computer, then you can use BB Edit and I believe VS Code. I'm not 100% sure about Sublime. If you have Windows, you actually can't use BB Edit, but you can use Notepad++, VS Code, Sublime. Excuse me. So yeah, depending on what you want down the line, you can also change it. So let's say you want to start simple, which I recommend doing. So if you are on Windows, I would just recommend starting with Notepad++. So you can say Notepad++, download, and yep, it's this little lizard one. So you can download it. It'll take you to the stable auto update triggered version. That's perfectly fine. And then you can download it for whatever version of Windows you have. So go ahead and download. And then if you're Mac, I recommend BB Edit. And I believe you can download it from here. So yeah, the newest release date was about a month ago, so it should be pretty up to date because it's widely used. So I'll go ahead and send that, and then also the Notepad++ in the chat. And we'll go ahead and take a minute to get everyone up to date. It shouldn't take too long. It should just be a matter of installing. So I'll pause the recording for now. Okay, so we have our text editors installed. Last week we started playing around with the print function, and I believe we just created our first Python script where we had printed hello world last week, which is good. So this week we're going to dive a little more into organizing scripts. So yeah, go ahead and navigate to your session. And because now we have our stuff in GitHub and we have a text editor, if you want to make a new file, you can just make a new file here. I just personally have preference for creating stuff at the command line because I can automatically assign the file extension without issue, which is a little more difficult to do if you're just trying to find the extension in a list. So I usually initialize the file here. So I would recommend for you to create something called comments.py. So I'm going to remove my old comments.py and make a new comments.py. So comments.py, and remember you could use the touch command to just make something without opening it. So now I can navigate here, open comments.py, and it should show that I'm working on this file. So I'm going to zoom in a little. And get rid of this, all my Hive stuff. All right. So, as a reminder, and this is a really good segue from Victoria's question, if you put that interpreted directive at the top of your script, it will tell the script that you're running Python code in it, and it will also highlight your stuff appropriately for Python, depending on whatever text editor you have. This is also nice because then if you run it at the command line, it automatically knows within the script that it's Python code. So, I'm going to briefly go to this snake file. And this is way more complicated than you need, but I just want to show some examples. But see how here I have these things blocked off. Like this whole thing is highlighted in orange and has information. This has like a pound symbol in front of it. So these are called comments in Python, and all languages have some form of comments that you can use. And this is just to annotate your code because you want your code to make sense if you are reading it, or if future you is reading it, or if somebody else is reading it. So we're going to dive into the different kinds of comments that we can make today. So what I'm going to do is say, let's print something. So print, we can say hello world again if we would like to. And we're going to open this terminal. I'll clear this real quick. And remember, when you're trying to run a Python script, you say Python 3 and then the name of the script. So we say comments.py and it prints hello world because that's what we told it to do. So let's say that this is something of importance in the code. It's a major point or a debugging method. I can say inline comment. And it's now highlighted green because it's not part of the code anymore. So generally with Python, anytime you are putting something with a comment starting with that pound symbol, anything after that on the same line, on its own line, is completely ignored for the whole line. So if we do that again, so Python 3 comments.py, we still see hello world. We see no trace of this whatsoever. So we can go ahead and start doing some different versions of annotation here. So we can do, and this is just a style that I personally prefer. I like my comments on their own lines ahead of the code because a lot of times I'll have code that's like multiple lines long to do one thing. So here, for example, is validate output length, and it's like 4 lines worth of stuff. So if you want it on your own or on its own line, you can also do that. So in this section, I am printing the names of some of the attendees. And so I can say print Claudia, print Julian, print Victoria, print Amber. So you can print as much as you want, and this is helpful having multiple lines. And as we see, if we run this again, it's still printing Hello World because we gave it that instruction. And now it's printing all of these names, which we told it to. And as we expect, it is completely ignoring any of these comments that we have assigned. So now I want to dive into some multi-line comments. So one of the things that I really like to do with my scripts is give instructions on how to use it. So in other cases where things start to get more complicated, say like this is something that I've been working on, I have this thing called argparse that I'm using where I'm allowed to give command line arguments to it. And we're going to actually have a whole section dedicated to how to do this and what the purpose is. But for now, just know that that means I can give it these little options when I'm running my script. So it's a little annoying because if you're running a script, you return to it, you're like, I don't remember how to run it, what it looks like. So you want to always have some sort of set of instructions. So here I have an example where it says Python 3 process bigwigs.py, and I have my different like metadata, my features file, the output, the assay that I'm using. And then I have all my setup stuff here. So this is nice because now if I want to run the script itself, I've given myself a very easy reference for what it should look like when I run the script. And this is less difficult, say, with like something that you just run as is. But if you want to have lines or comments that span multiple lines, you can do 3 apostrophes. And these can be either single or double apostrophes. You can put whatever you want here, and then another set of 3. And even if we do this, it's all highlighted orange, which indicates that it is within this comment block. So if let's say we delete this here and just put everything in that comment block, literally nothing happens because we have essentially just given the Python script a bunch of text to store without executing anything. Whereas if we take it out of this little comment block and we try that again, we see that it's printing again. So this is really helpful for a number of reasons, including like instructions for yourself, but also for me, I like to debug my code like this. So going back to this kind of more complicated script, if I'm running something down here and I realize that there's an error above, Python is executing your script line by line. So I'm like, well, I don't really care about seeing all this complicated stuff. I just want to see if it makes this directory, for example. I can just do this and flank the entire region by these apostrophes, and now none of that code is being executed. So this is really nice for debugging. It's also nice if you want to preserve scratch code. So if you're like, I am trying something new, I know this works, but I just kind of want to keep it here for now, you can also just comment that whole section out very easily without having to worry about it. So a lot of utility here in terms of both like information on documenting what you're doing for yourself, for your future self, because if you return to code, you want to know what you did and why, but also just for actual like working with your script. So now we've discussed some comments. Okay, so I want to give an example of some code that looks a little bit complicated. So I'm going to create this little section here where I'm printing the numbers 1 through 20 and printing the names of all my pets. They are not all my pets anymore because it's been a long time since then. But see how I say for I in range 1 through 21, print I, and I'm getting this 1 through 20. And then I have these things called pet names, Stella, Blueberry, Sunny, Bird, Zosha, and then for pet and pet names, and it's printing all of them. So notice in that previous example that I had going, I had printed all the names of people in the not all of you, but some of you that are attending the session right now. And every single time that I wrote your name, I had to say print Claudia, print Victoria, print Julian, print Amber. Whereas here with this pet names where I'm saying Stella, Blueberry, Sunny, I only have to type print once. I don't have to print every single time that I'm doing something. So now we're going to start transitioning a little to the concept of variables. So in this case, I have essentially assigned a variable called pet names and said that pet names is a list of these values. So now I can actually add, let's say, and just for reference, like this is a for loop, which we'll learn about a little later. I don't need you to focus right now on how that all works, just the fact that we're using variables in this context and that it is useful in a broader context. So let's say with this script, I'm going to say print attendees, and we'll say attendees equals. So one of the things about Python is it uses the assignment operator equals. This is how you're telling Python that you are assigning a variable. So we can say attendees equals and just say, for simplicity, Victoria, because you're on the top left of my screen. We'll say attendees Victoria and say print attendees. And now when we run this, it just prints Victoria. So we didn't tell it to print Victoria directly, but we did tell it to print this variable, which is containing the value Victoria. And the nice thing about assigning a variable in Python is you can assign a variable to quite literally any data structure. I have assigned variables for entire thousands lines long data frames, and it's been fine. So this is really kind of like when you learned in algebra. Like this is just where you assign anything that is either unknown or in this case, known but kind of variable. Or I guess that is why it's called variable. Yeah, so let's say now we want to make this a list. And we'll learn about the actual syntax for lists later, but we just put a little bracket here, and now I can say print Victoria, Julian, Claudia, Yamira. I'm just going in order of people on my screen. There's no preference here. And so now if we print this, notice that it prints that whole list because I'm saying this variable is a list of names, and when I print it, it is printing the whole list of names. So this is just storing information for us. So a lot of times that you're writing scripts, going back to this kind of more complicated script I have, there's a lot of times that it becomes necessary to store this information. So again, this is more complicated than you need to know right now, but see that I say average signal equals and then have a bunch of code. And then later, I just use this to print my average signal. So you're assigning either code or values that change throughout your script. So if your input is changing and you want to do a calculation, this is going to calculate it for every input that changes, which is one of the powers of variables. A lot of times in Python, you don't want to have everything hard coded. You want to have, and this goes for any language that you're writing in, but you don't want to hard code anything. You want it to be dynamic enough that you can reuse your code in another context. And that's also why I say use the scripts that have instructions on the top. Make comments in your scripts because there is a chance that in 3 months from now, you're going to go back and be like, I remember writing something like this before. And you're going to want to use that code and be like, oh, yep, here's the exact session where, or section where I did that thing. And then you can copy it and reuse it, or just reuse the script itself if it already works the way you need it to. So, to expand a little more on variables, there are some limitations with variables. So you cannot start variables with a number. So see how this is red, whereas before, if I assigned a variable, it was black. That's because in Python, if you start something with a number, it is making an assumption about the data type, and that is not something it assumes for a variable. So let's say we just write this. Even if we don't print anything, even if we are just assigning the value and we run the script, it's going to tell you that there's, yeah, an invalid decimal literal. So it's trying to make an assumption that this is some sort of value, that it's not. We're just trying to assign a variable. So generally, you can't start something with a number. You can put a number at the end of it or in the middle of it, that's fine. But you cannot start it with a number. Python needs to know that it's starting with something kind of alphabetical. You also cannot put a hyphen in it because in Python, as we'll learn a little bit later, that hyphen actually is a subtraction symbol. So if we do something like print 3 minus 2, it's actually trying to carry out a calculation. So this thinks that you are trying to subtract and minus animal, which also doesn't work. So if we run this, it should also yell at us, but with a different thing. Yeah, cannot assign to expression here. Maybe you meant equals instead of equal. It's like I don't know what you're trying to accomplish here. So that's also illegal. You also cannot have spaces, and I believe this was something we discussed a little bit earlier in the sessions, where generally spaces are not good to have in variable names and file names when you're doing bioinformatics or just informatics in general, because spaces are now interpreted as this and this being two separate things. So now if we run that, say python 3 comments.py, it says invalid syntax. It's like, yeah, I don't know what you're trying to accomplish. And one thing I'd like to highlight here is troubleshooting code has always been particularly irritating. It is probably one of the biggest things that I deal with on a day-to-day basis is trying to troubleshoot why something's not working, why something isn't calculated the way it's calculated, why something isn't saved the way I want it to be saved. So sometimes there's a matter of just looking at the actual error itself. Like I had recently been doing an analysis where I was getting some invalid syntax error and I was trying to run multiple jobs that kept failing only to realize I forgot literally a single character in my script. And it was annoying, but once you read this error, you see that it's pointing exactly to where the error is happening. And oftentimes, especially if you have a longer script, it will tell you the line number, which is why text editors are nice. So here it's telling me this is on line 3 that this error is happening. So I can say, okay, let me look at line 3 and fix this. So it points you automatically to where the error is, both in terms of the line number and the actual part of the code that it doesn't understand. So these troubleshooting steps are going to be immensely helpful down the line because you're not going to be perfect. You never will be, and that's okay. Nobody is. But you're going to end up coding things and have trouble trying to figure out what order of steps to execute. You forgot a comma. I think I was coding with Paula recently, and every time I tried to print something, I forgot the closing parenthesis. Like, it happens, but you need to learn that when those mistakes happen, you just look at the mistake. You look at whatever the output is. Google is your best friend as well. And more recently, especially for things that are like syntax related, you can also use AI, though I recommend a little caution there because you might be at a stage where you are just knowledgeable enough to know that you can execute code from ChatGPT, but not quite there yet to know what you're executing. So I would still recommend being cautious. It is a good tool to have, but not something that you should entirely rely on. With that said, it is really helpful for troubleshooting. So
Hey,
if
can I
you,
ask you a question real quick?
yeah, of course.
Are there any text editors that you know of that will catch those syntax errors for you? Where they give you like a little squiggly line or an X with it? I know in R it's sometimes there's an option if you forget to close a bracket, for instance, that it tells you something like invalid, just so to avoid what you basically said, where you maybe forget the one symbol that gives you a headache.
Yeah, there are. There's also, I think, different plugins or options that you can toggle on within. So I think for mine, like style configurator, preferences, I don't know where the screen went. Oh, indentation, highlighting, searching, auto completion. Yeah. So I think like it'll say function parameters hint on input, and then I can auto insert. Like if I do this, I want it to automatically close with a parenthesis, but I have had more trouble doing that than having it active for myself because a lot of times like I'll type something and want multiple lines worth of stuff with multiple arguments going on, and then it's completing stuff for me before I'm ready to have it done. So I disabled that for myself intentionally, but you can have it on so that stuff like that's not happening. You can have the auto completion, you can have like invalid syntax. And I think there's also for Python specifically some beginner friendly, I think they're like IDEs. I don't know what that stands for, but like interactive development environment maybe. But I think they have some where it will kind of like hint, hint, nudge, nudge, that's not correct for you. So there are things that do that.
Great. Thank you.
Yeah, no problem. But yeah, in this case, this syntax error is really simple, but if you're running like longer code, it is helpful to know as a skill how to troubleshoot. So being able to use your resources, honestly, Google is really, really helpful. Like there's a lot of times I will literally just verbatim copy and paste my error and be like, what is it doing? And it will pop up some information on how to fix the thing that I'm running into. So don't be scared of errors. I know it's not fun because you're used to things going right, at least most of the time with some other science, but here it's really common that you're gonna have error after error, and just learning to get through that is important. So in terms of going back to variable names, I want to highlight these are some illegal variable names we just went through, but all of these are legal variable names. So we have no spaces. If we want a space, we can put an underscore. If we want, we can actually start it with an underscore. We can vary what things are capital versus lowercase in any way that we want. We can add numbers as long as they don't start the variable name. So really, there's quite a lot of flexibility with how you can assign your variable names. The one thing that I really recommend that you do is, in some capacity, make it so that your variable names are informative. So when you're writing a script, you don't just want some variable, because you absolutely can assign a variable that looks like this and say um, dog. That's completely legal to do, but it is in no way informative. If somebody's looking at your code, they're like, what on earth is this person doing? So you don't want that. You want your variables to always have some information about what you're doing. So in this, for example, I'm saying I'm defining a set of columns that is required to be present. I need accession, sample, target, and file type. These are absolutely required for what I'm trying to accomplish. In another situation, for example, let's say, yeah, earlier we were talking about average signal versus max signal. Like those things when you're working on a script actually mean something, so that when you're trying to write logically, you can write logically. And a good way to kind of demonstrate that is you can also kind of write your code in your head in English first and then start adjusting it for syntax. So something like, I want to make a list of people attending. No, we'll try something else. Too many lists of people attending. List of plants we got going on. So we'll say blueberries, peppers, tomatoes. So we'll say that's my list, and for fruit and list, print the fruit name. So this is not syntactically correct, but as you are thinking through the process out loud or even just in your head, saying like, these are my fruits are in a list, I want to print the fruit. So you're now using those variables. This is illegal, so we're going to say list one actually. But saying, okay, I have a list, I have fruits in a list, and I want to print the fruits in the list. So this is just getting used to the idea of like thinking through and trying to make abstract thoughts into actual tangible code. So using variables that actually make sense and mean something help you think through those things. Because otherwise, if I said this, now I'd have to say for fruit in ASDF, which doesn't really mean anything. Like that's not helpful. If I get stuck on something, I'm not going to be able to debug very easily. So be a good coder, code things in a way that makes sense. All right, we got through this way faster than I expected because all of you installed text editors very fast. So I am briefly going to start switching over to session 5, and maybe we can play around with stuff like that. All right. Well, we will switch to session 5 because this is moving a little bit away from some of the Python stuff. I'll go ahead and send that in the chat. So I guess before we move on, um, what was supposed to happen this session was we got our text editors installed. We started playing around with variables, executing actual script from in our text editor at the command line. I assume everyone is caught up, no issues with that. No? Okay. Sounds good. So as a brief touchback on last session as well, you should be able to now, if you open your GitHub desktop, go to Python focus group, and it should indicate that you have changed or created a comments.py. So here we see that I changed a bunch of stuff. So I can say I select comments.py and say add variables. And I can commit this and then push it. So this basically is just syncing your GitHub repository, which is good practice. And also a lot easier than doing it at the command line like we were doing before. So yeah, okay. So we're going to talk now about aliasing, and this goes back to making things convenient. So a lot of times when you're coding, see here how I have mntc users wiki documents GitHub Python focus group. Every time I want to navigate here, I do not want to type cd and then that whole directory. So what I can do is create something called an alias. So now if I just typeghub, it automatically has now changed my directory for me. Now you might notice that if you typeghub on your command line, it is going to tell you the command is not found. That's because I assigned the command in my profile on my computer. So this is going to be really important for Hive specifically. So say nano, actually not, we'll do less.bash rc. Quick note, you have to be all the way in your home directory. And this might be a little annoying because depending on the operating system you have, this is going to be a little more complicated a part to deal with. But if we do ls-al, see you have all these things that begin with a period. But if I do ls, I only see Anaconda 3 and Anaconda, the sh file for installation. So that's because this A is basically saying list all files that are here. And generally, with anything on your computer, anything that begins with a dot, like a period, is hidden from you. It's hidden from view. It's like configuration stuff, stuff that runs in the background that needs to be there, but that generally the people who made your computer don't want you interacting with. But once you start getting more familiar with computers, it's okay to interact with some of those things. So in my case, for as a Windows user, I have a file called bash rc. This is the thing that configures my terminal. This is what tells my computer how to run the stuff at my terminal. And if you are on Mac, I think you might have a ZSH-RC, you might have a bash RC, you might have a ZSH shell. Like there are a lot of different variations of this file. You might have a bash profile, a dot profile. So this is where it gets a little confusing depending on what you're running. So as a brief note, on how to distinguish some of these files, and this is especially helpful for cluster environments. Bash RC is generally what is run if you are not prompted to log in. So I can just open a terminal. It's not asking me to log in, and I can just run stuff. So it's running bash RC. Whereas dot profiles are really helpful. Let me actually go to Hive and demonstrate this. So let me get my Hive. Oh, you know what? Really quickly, this is a good example. So see, I just typed Hive and it's prompting me for a password. If any of you have used Hive before, you'll probably realize that you have to type SSH, your username at hive.hpc.whatever. I don't want to type that every time I log in every day, so I made an alias just called Hive. And today is how I'm going to show you how to do that. But I paste my password, I log in. I'm going to clear my screen because I like my stuff clean. So now that I'm in home, we see all these hidden things, but notice that there is a bash RC, but there's also a dot profile. So remember I was saying that when you log into Hive, you see how it asked me for my password? It prompted a login. So when you are in a situation where you're logging in, you use a dot profile. If you are using just a terminal where you're able to open it, you use a .bashrc. So it is confusing, and you don't need to understand all the crazy specifics. Just at your own terminal, try to find a file that looks something like that. So if you have a bashrc, zshrc, something of the sort. And the way we can test what your thing is using is if you have one of those, like a bashrc, I have a long bashrc, but you can say like echo hello. Yours might be a little emptier than mine, but let's say somewhere down here I can say echo hello. And now if I open a new terminal, it should say hello. So if you have a dot profile, a dot shrc, dot bashrc, and you're not sure which thing is being executed when you open your terminal, just put echo hello in one of them. If you open a terminal and it doesn't say it, it's not that file. Then remove that and do it to a new file until eventually you have narrowed down which of the files is being executed. So the reason I say this is all of this stuff is executed the moment that I open the terminal. Every single thing in here is run the second that I open it. And that includes creating aliases. So notice here that I have all sorts of aliases, and I've put aliases to improve CLI usage experience. So I have one called Hive. So I say alias Hive equals SSH Vihagani at hive.hbc.edu. So what I'm doing is telling my command line every time I type Hive, execute this command. I'm basically creating a shortcut for my terminal to know. So similarly, I have created this alias calledghub that it CDs into MNT, C users, Viki, desktop, GitHub. So what we're going to do with all of you is actually create something for Python focus group. So what we're going to do is have our fresh terminal. So navigate to your Python focus group directory and then click pwd. So this should give you some sort of file path for whatever you need. All right. And then just copy this for now and open it briefly in a text editor, sticky note, literally anywhere you can copy and paste it. And the syntax for this is always the same. You write alias in all lowercase, and then you write your variable. So our variable in this case will say pfg, and that's going to be Python focus group. And you're going to set that equal to whatever command you want. So this is going to be treated as its own command, so you have to flank it with quotation marks, and you put the command in the middle. So this is just the directory, so we can say cd. So what this is now saying is create an alias called Python focus group and set that alias equal to cd into this directory. So now, I think just to keep consistent with my terminal or my syntax, I might delete some spaces, but we can go into our file and put that there. So yeah, I'm going to delete my space and replace it with double quotation marks just because that's how I have my other stuff in here. But it shouldn't matter. All of those should work for you. So you should have alias, whatever you're defining it as, equals, and then cd. And this is, for me, I find it a little easier to use nano for bash RC and stuff because it's hidden from your file system. Like if I try to go to, I don't even know. Yeah, I don't even know how to get home from here. I think I'd have to go to Ubuntu, Linux maybe? Yeah, no, I can't even open it. So for stuff like this, especially as a Windows user, it might be easier to just use Nano for this case. But here we have our Python focus group. We're going to control X, save it. And now there's two things you can do. One of them, in my experience, is easier. You can either source the file itself and cause it to run everything in that file again, and it will basically reset your terminal, or you can just exit and open a new terminal. I just like to exit, open a new terminal, especially if I'm not logged into anything. And now if we type PFG, you should now be automatically taken to your Python focus group directory. So you can create aliases for anything. You can, one of the things that I like to create aliases for is ls. So when I do ls, see that these have stars at the end. This has a slash next to it. That's because ls for me is alias to ls-f, which adds one character to denote whether it's a directory, a file, an executable file, an alias. So it gives you a little bit more information about the stuff that you're looking at. So if we go back to the bash RC, I can show you some of those aliases that I have, and these are optional. You can not have them if you want, you can have them if you want. These are the ones that I like to have. So I like to alias ls to ls-f. That's my favorite one, and honestly, I recommend that for everyone just because anytime you want to see if it's a directory, file, this or that, it's a lot easier to see. It's kind of like the equivalent of if you're opening your terminal or your file explorer and you see the little symbol for a folder versus the symbol for a file. It's giving you information just upon first glance. So that's really informative in my experience. And then remember, I think we were talking about in previous sessions when I was running RM and MV and copy and stuff like that, I have them aliased to a dash I so that it confirms me if I want to remove something. So if I go to Python focus group now and go into session, let's say 4, and do remove Python script that I created earlier, it asks rm remove regular empty file. For you, it might not have done that because for you, rm just means remove. I am doing rm-i every time I run rm. So it's dash I for interactive. It's basically asking me, hey, can I delete this? And I have to tell it, yes, you can delete that. That's fine. So this can get annoying if you have stuff nested, which might require you to use like force and stuff like that. But I like it because it's prevented me from, on many occasions, doing stupid things. You can also do, I like a lot of these CD type things. So like in Hive, I like having like easy links to navigate to my personal folder because I don't want to navigate through Katie Fink group users. This is like I don't want to go through all these nested directories every time I log in because I know where I want to go immediately. So I just set one that says like Fink Lab and say CD Fink Lab and it takes me to where I want to go. I have one for desktop because on Windows, it's not super easy to navigate to your desktop. So now if I say desktop, it just takes me to my desktop. So there's a lot of these little tricks that you can do to make your life just easier. Particularly like SSHing into something, navigating to a really nested directory. And in my case, I like activating a Jupyter notebook, but it requires me to, one, navigate to my GitHub directory, two, activate the environment, and three, launch a Jupyter notebook. So that's three commands that I run on nearly a day-to-day basis, back to back every single time. So instead of doing that, I just run this one like jupe, and it will do all of those things for me. So this is particularly powerful. Um, I really recommend if you find yourself running things very frequently or like really long paths that you don't want to type consistently, I recommend just creating an alias. They're very helpful and just nice to use to make your life a little bit easier. So yeah, I think that is, yeah, so we got through some bash aliases. I'll probably move this, do some reorganization, put this in session 4 so that we can start session 5 with data types. So yeah. Are there any questions for today? So just as a brief recap, we installed a text editor, we created a Python script, ran some stuff in the Python script with different kinds of comments, with different variable names, and we've now practiced a little with aliasing. So next time we start, we can just type PFG to go straight to Python focus group. So yeah, are there any questions or comments? All right. Well, I will release you 10 minutes early. All right. Thank you all for coming.